Right. We are obviously getting started with our discussion just now, and we're going to be looking at a couple of things. But most importantly, we shall be looking at the notion of what we call the modified Euler's method. And in view of the modified Euler's method, we're going to be looking at this example given dy dx equals x plus y at 0 is 1. Find a solution in the range x lies between 0 and 1 in this in steps of 0.05, and the solution is going to be written as follows. So obviously we all the time in mathematics, if we are to write a solution to a problem, we first write down the problem or the question, and it is dy dx equals the sum of x and y at 0 is 1. And because we have that, the conclusion thus is the summation of x and y equals exactly x and x plus y. But we remember our old friends, and they are the predictor and corrector in view of the modified Euler. The predictor, as said already, is our friend from yesterday's discussion and days prior. It's of this form here, and today I'm going to present also many other different forms of the predictor formula and many ways of writing the predictor formula. But having the predictor formula, we also have the corrector formula, which is this one here, and then we have h over 2, and then we have f x I y I. We take the average with f of xi plus 1 together with yi plus 1 predictor, and we close like this. So these are the predictor and corrector formulae that we're going to use, and we proceed to use them accordingly. This is not, it's a good one because yesterday we did a giant question, but today we're going to do two short and then the exam. Okay, right, so what do we then do first? First, we must obviously note down the the initial value. So it's y at 0 is 1. So in other words, we have that y at 0 is 1. And what does this mean? Well, it gives us two values. It gives us x0, which is 0 from here, from the argument, and but also it gives us y at 0, which is 1 there. Okay. Now, with that said, this becomes a prelude to the predictor calculation. So I feel like I need to just write that predictor like I did yesterday, just to avoid a potential mix-up. So the predictor, it helps to write the predictor step, and then you can then write that we are dealing with the predictor here, and we have the initial value given, which means x at 0 is 0, and y at 0 is 1. And then now we're going to look at a couple of other things, like your predictor. Right. So in other words, like we said, uh, obviously, that the predictor is given by our yi plus hf xi yi. Okay, this is Euler. Is Euler's formula, this one. Right, so, but now having the x0, y0, it means that what we need is a y1, so we need y1 of the predictor. And it occurs when I is 0, because 0 plus 1 is 1, but when I is 0, that gives us y0 plus h. Then we have f of x0, y0. And then now we have this. So the next step, obviously, with the predictor and the corrector is not different, is to identify the things we have up here. Okay, but we need to remember something. We know that f xi yi is is actually the sum of the x. For this question, is the sum. So this means x0, y0 is going to be the sum. So x0 is 0 and y0 is 1, and the result is a 1. Okay, so we found this one. We have h here. What is h? H are the steps. What are the steps? Right, so the steps are 0.05 according to the question. So we have h, we have y0, which is 1. Okay, we can find y1 of the predictor. Now, what is y0? Is clearly 1 there, plus the steps 0.05. This one here is 1. Okay, 1.05. Okay, and this here is y1 for the predictor. Awesome, awesome stuff. Right, after we got the predictor, we simultaneously get, or subsequently we get the corrector as well. So now we go to the corrector. Okay, what is the corrector? We first write the formula. Like you said yesterday, it's best you write down the formula first, and then you can examine and see what inputs you need to get the required output. So now you have this formula for the corrector, but now I must indicate that we're also going to be looking at a couple of other predictor and corrector methods for other, like your Adams-Moulton, etc. Your Bashforth methods and so on. They have their own predictor and corrector formulae. As much as this one also is, these are the predictor and corrector formulae for the modified Euler. Okay, now we have what we actually have got before, but we need y1 of the corrector. So to get y1 of the corrector, it occurs when I is 0, giving us y0 plus h over 2, and it gives us x0, y0, and it gives us f of x1, y1, p, like this. So we need basically two big formulae. What do we need? We need fx0, y0. Let's just, so fx0, y0, what is it? According to these, is x0 plus y0. Okay, is a sum according to this question. X0 is 0, y0 is 1. We saw that. So, and this means that x0, y0 is 1. But we also need this one, this giant one. So this big one, it means we have the x1, y1 predictor. And then now we have got the predictor before. So this one is the sum of the components of the function. So it's x1 plus y1 predictor. What is x1 actually? Okay, right. We have got x1. What did you get x1 to be? Like we said yesterday. Sorry, if x0 is actually 0, what is x1? Okay, so we said yesterday that x1 is going to be the h plus the h plus the x0. Okay, so which means that in the according to the steps, so it's going to be like 0.05. This one. Okay, just to add to x0, you just add 1h to get x1, and then to get x2, you add 2 of the h's. You multiply this by 2. And you add to x0. Okay, we saw that yesterday, but we must add that to the predictor y1 we got. And that one is 1.05. So it's 1.05. 1.05. So what is the answer to this here? So it is exactly, let's just make sure we get the correct answer. So this is 0.05 plus 1.05, and it is 1.10. Okay, that's is correct. So you have f of x1, y1 predictor is 1.10. So in other words, we've got this one, we've got this one, we have y0, we have h over 2, and it's all good and well. So we can even go here and say y1 corrector is y0 plus h over 2 into fx0, y0. fx1, y1 predictor. What is y0? We saw that it is 1. The h is 0.05 out of 2. And then we have x0, y0. We saw that it is 1. And then this one here, we got it here is 1.10. It's 1.10. And then we get y1 corrected. Okay, let's just do this one. So it's 1 plus 0.05 divided by 2 into 1 plus 1.10. Close. Okay, it's 1.01. Okay, it's 1.01 there. Okay. Okay, so yeah, I'm gonna write a bit more decimals because obviously I'm just using um just a second, let me use a calculator on the screen. Because now this answer is 2 rounded off, you're gonna have huge truncation errors. So let us use this one here. So that we don't have like very huge truncation errors. Okay, is this one. Okay, now we're gonna have 1 plus, and then we have the fraction here. We can use this one. Doesn't matter. You can have 0.05. You divide by 2, hoping that this will just interpret it well because right 1.10, and then you close, and then the result. Okay. Right, it's okay. But that is what we're able to then get. So it gives us the answer. So if we do all this here, we're getting that. That's fine, never mind. So if you go to if I go to computational and then yeah, that's what I want. I want to make sure that I sort of get the correct answer. Okay, I went to computational and it can do the fractions the correct way. So it's 0.05 here. And you have here 2. You have here 1 plus 1.10, and then you close like so, and then the result. And now you need to press the SD button. Where is that? Because I see now the fractions. Is it this one here? Let me see. I need to just check where that is gonna. Okay, there's a button to press this one. I needed this answer, and this is the answer. Okay, so you see, before it was not giving me the answer. Okay, so it does not give me the correct one. So it's 1.0525. See, I was wondering if I'm making a mistake or what. Okay, so the answer to this is exactly this. Okay, so we are sorted. So, wait, that's. All right, so now then this is the correct answer. What is the correct answer? Right, the correct answer from the calculator is what I expected. So it's 1.05 here, then 2.5. Okay, so this is the y1 of the corrector. Okay, so the calculator must just be set properly as well. It's an observation, otherwise one is just going to get answers that are sort of incorrect. Then the next thing is we got y1. Then we need to get the next y value, because remember, we must deal with x0 is 0, x1 is x0 plus 1 times h, which means therefore that, yeah, what I'm really saying, because I'm trying to train here. So obviously this one is x0 plus that, leading to the fact that in general, like we said yesterday, just recap on that, that xi is always the initial value plus I h. Okay, so with that said, we're good, and we can continue and use 0 plus 1 times 0 0.05, which is, because the h is 0 0.05, and therefore this one is 0 0.05. So we're going to have x1, but we're going to continue to x2 as well. What is x2? So x2 is going to be 0 plus twice, like this. So what is the answer to this? Right, we saw that this one is going to be just like 1.1, 0. Okay, so and then now let's get no. Right, no, it's 0 point. Okay, so if you multiply by 2, my apologies there. So this one is 0.10. Okay, all right, I'm mentioning that because it is the result we want, because that is the ultimate one. That is the ultimate one. Okay, so yeah, so we stop here. Why do we stop here? Because that is the range given at the beginning of the question. Okay, right, so we did everything up to the x1, so up to y1 corrector, so we must proceed now and do the predictor again. Okay, the predictor was done for at what value? So the predictor was done to give us the y1, and now we need the y2. So, but obviously, like we said yesterday, just write the formula the whole time, and it's going to make a huge difference in helping us to. Okay, this is the Euler, but when we're doing the modified Euler, we call it the predictor formula. But now we need from these y2 predictor, because you got y1 predictor. So, but y2 occurs when I is 1. So we have this. Right. And then now with this said, what more do we need here? Well, we need the rest of the things, the inputs. Right, so now what are the inputs? We need the y1. Where is y1 coming from? And what is x1? X1 we know how to get the x1, x2, x3. Okay, but the y1 is always going to come from the previous corrector step. So, which means at this point with x1, y1. Okay, according to this formula, according to this question, it is the sum of, yes, please. Okay, thanks. Okay, just a minute. Okay. Okay, thanks then. All right, we are back. Okay, we are right back now. We're right back now. My apologies, I just had to grab something quickly. And then we're finding the summation of this, or is x1, y1. So what is x1? Okay, we saw that x1 is 0.05. Okay, and then now what is y1? Predictor? Corrector, excuse. All right, so it's 1.025. 1.025, right? Hey, 1.0525. Right. So It's 1.0525. 1.0525, and then we find the sum here. Okay. So we're back. Okay, so let's do this quickly. So 0.05 plus 1.0525. Okay, what we're getting is 1.0. Oh, it's 1.1. So this one is 1.1025. All right. And okay, so we've got this one. We've got the H. We've got the Y1. We're good. So we can get the predictor, meaning Y2 predictor is Y1. What is the Y1 corrector? Y1 corrector is what we've put here, which is 1.0525 plus H is the step size in steps of H, and this one, the function is 1.1025, and now we have a Y2 predictor. Okay, so this one here is 1.0525, 1.0525 plus 0.05, and then times, yes, 1.1025, you close. And this is 1.10765. Okay. And this is the Y2 predictor. Okay. Oh, that's what we got. So this is Y2 predictor. And then now we're going to proceed to get the Y2 corrector. Now, this Y2 predictor, right, has been obtained, but we're going to say more about this here. Right, we're going to say a little bit more about this. Okay. Corrector. Let's look at the corrector. First, the formula. Yi plus 1 corrector is yi plus h over 2 into fxi yi plus fxi plus 1 yi plus 1p. Okay. All right, so we need y2 of the corrector. Y2 corrector occurs when I is 1 here. So it's y1 plus h over 2. And then we have f of x1, y1 plus f of x2, y2 predictor, close. Okay. So what do we do now? Okay. Okay. Okay, sorry. Okay. I received your message at some point, but yeah. Okay, sorry. I did not. Somebody was using my phone at the time, so I could not see your message. So yeah, noted. So yeah, we noted, please. Somebody was using my phone. I could not see the disconnection issue. All right, so somebody just brought my phone now. They borrowed. Okay, so now let's check the rest of this. What do we need? These things, we can even write them underneath this formula. So like we can see that we need the F's. So according to this question is the sum. Okay, this is not a long question like yesterday's one. And then now we have x1. X1 we saw that is just the first, is the x0 plus h, just one h. So we have that, and then we have the y1. The y1 here obviously is going to be the y1 of the predictor. Let's see. Y2 corrector. Yes. Okay. So yeah, the y1 is the one we got. Okay, because obviously we have the y1 here, and the y1 is actually 1.0525. 1.0525, and then we get the summation of this. And what is the summation of this? Right, the summation of this is that we have 0.05 plus 1.0525. 0.05 plus 1.0525. Right, the result of this is 1.1025. Okay, so, okay, we continue. Right, so we have this. So that would be this part here. And so now we continue to get the other part. And then we have x2, y2 predictor. And what is x2? Well, we saw x2 is always from the axis, so it has nothing to do with quite the predictor and corrector. But now what is x2? X2 obviously is going to be twice the h plus. Obviously, it's twice the h with the x0, but x0 is 0. So that's why it's just twice here. Okay. Next, what is y2p? Y2 predictor, we got that one. Is this one? So it's 1.107, 1.107, 1.107, then you have 625. Okay, and then we get the summation. Okay, so we continue. We just need to do this one, which means 2 times 0.05 plus 1.107, 625. Okay, 2 times 0.05 plus 1.107, 625. 1.207,625. Okay. We got this, we got that. We have the y1, which is exactly this one here, and we're good. We can, in this space here, right, get y2 corrector, which is y1, 1.0525 plus, okay, we here, h, 0.05 out of 2. Okay, I need to grab the calculator here from within the screen. And then now you have this one, which is 1.1025. Right. And then now plus, so we here, we're getting this part here, 1.207625. Okay, let's just get this one quickly. I'm just use this calculator. So at this point, what we have is if we have 1.0525, okay, like this, plus, then we get a fraction like this, so that we just get quite correct answers. Otherwise, we need to avoid mistakes here. And then you put an open parenthesis 1.1025 plus 1.207, 1.207625 equals. Okay. This is the answer. Okay. So this answer is 1.110253125. Okay. 1.110253125. Okay. Good. So we're going to write it here just to make sure we have it as well. 1.11025. 3125. Okay, we're going to round off. There are truncation errors, and the truncation errors basically become errors between the approximated values and the accurate values. So in the process of approximating, we get truncation errors. Okay, now we have this. But this here is not yet the answer. This. Why? This is not yet the answer because this y here is a y that depends on mostly x1. Okay. I'm going to elaborate on the next presentation. So, which means we need y. So I'm going to write the following. Y to correct. Can use the approximate result. This is an approximated value. 1.11025 3125. Therefore, well, what it means is therefore it is the approximated value at the 0.1 and it's 1.110253125. Okay, what is the meaning of these? I'm going to write two columns. And then here in the two columns, we're going to write the predicted values versus the corrected values. Okay. Okay, this one is X. That's fine. This one is a Y. This one is f of xi, yi. And then there is yi plus 1. The corrected values are associated with this one, xi plus 1, yi plus 1, yi plus 1 corrector. Okay. What is x0? Is 0. Okay. And what is x something? x1 is this. x0, x1, then x2. x2 is 0.1. Okay, x0 is 1, 1.0525, 1.1103. This one is 1.1025. One point 0.5, 1076. And then 0.05, 0.1. Okay, these values were obtained in the former calculations. And then this one we got. Okay, we're going to just analyze this table. So this one is 1.1, 1.2076, 1.0525, 1.1103, so like we indicated yesterday, the effect of these and the shifts they experience, because this one here is an x0, but the x0 is, when it comes to the predictor column, so you can put P here for the predictor, right? When it comes to the predictor column, the predictor values that we got 1.05 for x0. $1.05 is the predictor, and that goes with x0, y0. And then the corrector that we got became 1.05, which is 1.05. And then now obviously we get the x0, it corresponds to an x1. So this one, it presents a shift because these values are like moved up like this. Because this one, this x1, it appears to be in the same row as x0, but it's ideally you could put it here, but that's why we put them so that this one is like this x1, it's here. And therefore this one here is actually like x2, and it gets the corresponding y of the corrector, which is corresponding to the y of the corrector is the actual answer, because it corresponds to the x at 0.1, which is what this y corrector corresponds to. It corresponds to the 0.1, but the 0.1 is actually the solution we want, which is exactly this one. Well, it means the approximated value that yields a truncation error, which becomes the error or the difference between the approximate value and the accurate or the exact. That difference is the truncation error. So you have this. So in the process of approximating things, we run into errors because when you get the exact, then there's a difference there. Okay, this is the table, and this is the answer. So the calculations can be summarized in this table. In this table can be divided like so, so that you have here the predicted and you have the corrected. Right, let's look at just one more problem and then we go to the exam. I have lots of questions with me for practice purposes, but yeah, the next one is quite short as well, but it's different from the one we are looking at now. If you look at another example, and this example says using the modified Euler, the modified Euler's method, obtain a solution of the differential equation. Dy dx, which is now x plus the square root, with step size h, which is 0.2, in the range. Right, x 0, 0.4. Okay. Right, so this is the question. And we need to solve this using the modified Euler. And yeah, it's going to be short. It's not going to be very long. And then we're going to go to the November exam. Now, let's look at the solution to this. What is the solution to this? First thing first, we say, what have we been given? Given that we have dy dx equals x plus the square root of y. And y at 0 is the initial value, but it is 1. Thus, f of x and y is x plus the square root. Now, with this said, what is the predictor and what is the corrector? We know those already by heart, but we just write them as a formality. And I'm going to look at variations in the next couple of minutes of these formulas that we learn. Yeah, okay. There are variations here, and we have this one, corrector is exactly yi plus h over 2. Exactly into f of xi yi plus f of xi plus 1 and then yi plus 1 predictor. Close. Parenthesis, like so. Now we are here, and this is what we need to do. Okay, so how do we solve this? Right, to solve these, we solve them in the usual way. So first predictor, and then corrector, and then the table. But can we have a quick way to just get the answer in few steps? Yes, we can. Now, I want to use a small little trick and see how that is going to fade out or how it's going to play out. Okay, instead of writing like too many things, we can just tabulate the values quickly and get the answers. You can write like everything we have. Like if we say, right, if we write everything we have, like everything, okay, I'm going to write the tools. X plus the square root. And then we write y is 0. And then we write, so that I do not forget, h, and then we write yi plus 1 predictor is yi plus h fxiyi. Then you have yi plus 1 corrector, which means you have a over 2. Okay. This one plus, okay, I want to use a quick tabular method, but just us doing the table quickly. I'm going to see how that is going to be, if it's going to be much easier and faster, most importantly. One thing that is very problematic here is the time factor. Beating the clock. This exam was supposed to be like 3 to 4 hours because of the too many calculations, but yeah, predicted values and then the corrected values. Okay, now you have this. So let's play around with this. X. What is X? Right, so we're going to see what X is. And then we're going to see what Y is. Yes, X, I, Y, I. yi plus 1 predictor. Xi plus 1. F of xi plus 1, yi plus 1 predictor. Yup. So from the xi plus 1, we have corrected. corrected values, and then the rest before that are the predicted
Hello?
values. Okay, yes, please.
Can we go back to the previous page?
Okay,
Is this exercise 2?
yes,
Where's the range?
it's between 0 and 0.4.
Oh, okay.
All right, thanks for noting that. Yeah, but between 0 and 0.4, because the age is 0.2, so they're like two steps, because it's like 2 times this. Yeah.
I have a question about the brackets. If you use the normal brackets, so how would the answer change?
Okay, if we use the normal brackets,
Yes.
what do you mean by normal? You mean round,
Yes, the round ones.
like this.
Yes.
That's a good question. That's a good question. Will the answer change? Well, yes. It would bring a different answer. Why? Because it would mean that x cannot be 0. And it would also mean that x can't be 0.4, but it's something between these. Yes. But obviously, if we use this one, we mean this. So x can be 0, is first 0. But I mean, it would raise a couple of questions in terms of, okay, but also, I mean, part of this question that maybe was missed out, I might have written on the other side, is that y at 0 is 1 for this question. All right, so that we start from 0. And then we get to 0.4. But if you use this round, it would mean this. So, I mean, the question will not quite be workable. Well, it would. What would the answer be? Okay. It would mean that you will have to look for, deal with the x values. If this is regarded as the range, this, what, according to the h values, what h would be here? So that would mean that we have 0.2. So you have to only do x equals 0.2. Sorry, x is smaller than 0.4, so it's strictly smaller, so it can't be 0.4. So you'd have to do only 0.2, and that'll be the end. Sorry, that'll be the difference. Obviously, this one is going to go up to 0.4 because x can be equal to 0.4, but with the round parenthesis, it would mean that you take things between, so 0.2. Okay. All right. Now let's continue. Okay, now we have that. Okay, I wrote y, y0 is 1 there. Okay, right. I want us to just do this table quickly with ease from just looking at these, and then we quickly fill in. Okay, it's possible to do that because we know that h is, but we know that y0 is 1. That gives us two things. It gives us x0 and it gives us y0. Ideally, we can call this xi, yi, so that x0, what is x0? Is 0. What is y0? Is 1. And then let's divide here like this. And then here, we need to get f of this. F of this means that according to this is x plus the square root. So it's going to be x plus the square root. So 0 plus the square root of 1 is 1. Okay. So now we need to get y predictor. Yes. And y predictor is this. What does y predictor mean? So it means that we take this y. Okay, because yes, we take this y. Very, very interesting this. Because now this is the x0, y0, but this one is the y1 predictor. Y1 predictor is going to have y0 plus h, x0, y0. So which means that you're going to take this y0 plus h, which is 0.2. So it's 1 plus 0.2 times this. So what is 1, 1? This y plus 0.2 times this, because we multiply by h. So 0.2 times 1 is it's 0. It's actually 0.2 times or plus. We're adding plus 1 is 1.2. Awesome stuff. Then, okay, you can also do this quickly, in particular under time constraints. We need to just quickly go to the table and stop the rest of these many other things that are long. Okay, now what is xi plus 1? Okay, so we can do the rest of this. 0.2. x1, you add 0.2, then you add another 0.2, it becomes 0.4. Obviously, we need to do x between 0 and 0.4. So we must go up to 0.4. Right, so yes, those are the x's. But then now we calculate the rest of the y's. What is xi plus 1? So if this one is x0, xi plus 1 is this one. 0 I plus 1 is this one, so it's just one shift. So you shift this up. So you write this one here and you write this one here. x1, x2. Okay, sorted. So this is filled in. And then now you just need to fill this up. Okay, so you fill this up. But filling this up, then you also need the yi plus 1 corrector. So what is this? So you need to say this x, this one, according to this formula. If you're finding the f function, you just take x plus the square root of y. So you're going to take x, which is this one, plus the square root of this. What's the answer? Okay, let's just check this one. Okay, you can use the calculator here on the screen. Right, so let's use this calculator. So ideally, that is going to be x, which is 0.2. The square root. Where is the square root? The square root of the y, which is 1.2. Answer. Okay, that's fine. Is D. 1.2954. So we can write it down here. Okay, need the right color here. Right, so which is 1.2954. We saw that that is the correct answer. Okay, because we're using this formula and then we're just getting the x plus the square root of the y. Okay, what is now using just the formula of the corrector in front here? We can quickly plug in and do this using calculator to fill this table up quickly. What is yi plus 1? So at this point, yi plus 1 must use the rest of the previous things. So you must use this one here for this, and then you must also use this one. So, and then you take the average of this with that, and then you divide by this by 2, the sum by 2, and then you multiply by h, and then you have the yi, and then that is the answer here. Beautiful. Okay, let's just have the calculator, please. Right, so if we pick up the calculator, so let's just do that quickly. So to find the y corrector by just writing the formulas on top of these, so we can quickly be able to see that according to this, it's going to be first yi, which is 1, plus, then you have your h, just use the correct. So our h is 0.2, and then you have divided by 2. So now you have the fxiyi, which is 1. And then now you have this this one here, which is 1.2954. And then you close, and then the answer. 1.22954. Okay, that's fine. So here we know is 1.22. $1.2295. Okay. And then this y we got is actually the y we use here. 1.2295. Okay, after we got that, we have the x and the y, and then we can get this one. Okay, according to this formula, the equation given, differential equation given is x plus the square root of y. So x is this plus the square root of this. Okay, just gonna resort to the calculator to make sure we get the correct answers here. So it is x 0.2 plus the square root of y. What is the square root of y? 1.2295. Okay, and then you get the answer. Right, so it's 1.30882, etc. Okay, we've seen the answer. So we have seen therefore that the answer here is 1.3088. Okay, I think that's faster. Sometimes you save a lot of time in the exam, so you can just write the formulas and quickly just fill in the table, but you need to just have your eyes running through the formulas that are going to produce the answers here. Now, let's go to, okay, once you get these, then you got the yi, you got the f, and then h, you know, you just need to add everything here, and it's going to give you the y predictor. So even this one is pretty easy. Let's just do it. Right. So to do this one also, we're going to resort to our calculator. And using our calculator, we're going to say, according to this, to get this one here, predictor, we need the y 2295 plus, then you have the h. What is the h? 0.2 here. 0.2, then you close. What is the f? Is 1.3088 close. Right, so is 1.49126. So this one here is 1.4913. And then now we're gonna come to this one. So this one is also very easy. Okay, we have seen the xi plus 1 is taken from the bottom here. Just this with that, just shift it just a little bit up. Okay, depending on however you look at it, because the xi plus 1 column. Now this one here, according to this formula, is the x component plus the square root of the y component according to this, and we plug the answer in here. And so what is xi plus 1? It is this. And what is the other one? It's this square root. So right, with that said, then we need to just pick up the calculator. And now we're gonna use the xi plus 1. To get here, xi plus 1 is 0.4. And then now the yp, you take the square root of it. And the yi plus 1 predictor is 1.4913. So this is 1.62. 1.62. 1, 2. My goodness me. Okay, so just a sec. Something happened. Okay. Right. Okay. All right. So this is not doing what I want. Right. So in the meantime, is just I'm sure it's going to restore to that. Right. So my point is therefore this here is 1.6212. Right. So with that said, then now we need to get the y corrector. So the y corrector, according to this, you take the yi and you do everything. Let's just pick the calculator again, and then I'm gonna sort of, because it was just leaving the bar. I think I might have pressed something else that leaves the bottom toolbar. Okay, right. So anyhow, you have the yi, which is this one. Let's just do now the corrector, which is yi, and yi is exactly this one, 1.2295 plus h, which is 0.22. All right. And then you have the fxi is this one here, 1.3088 plus the this one here, which is 1.6212. And then you close like this. Okay. Which is 1.5225. Okay. Right. So I need to do something here. This is just right. 1.5225. Okay. Right. With that said, then you are able to realize that that is exactly what is wanted. That is exactly what is wanted because that's 1.5225. Right. So the 1.5225 is the answer we want. And therefore, what does this mean? Right, so it means therefore that we have, yeah, right back. So it means therefore we have, yeah, just in case somebody has this red color, 1.5225 here, on this here is 1.5225. Okay, so these are the this is the value here that we get, but we get it at 0.4 for the corrector, and we use it as our I for the to initiate the process to get the rest. But yeah, this becomes the answer. But most importantly, we say hence. Right. We then say hence why. Okay, so this like is y0, y1. It's like a y1, this is like a y2. Correct. So which means that we have the Y2 corrector. And the Y2 corrector is approximately 1.5225. The Y2 corrector is evaluated at 0.4, which is 1.5225, like this. So this is the approximate value, and therefore there's a truncation error, which is the error between this value and the exact value of the function at 0.4. Okay, it's not quite of interest here because, but okay, I want to say this. Okay, we can make two observations like what is y at 0.2? Y at 0.2 is 1.2295. And y at 0.4 is approximately 1.5. Double to 5. Okay, so we got that estimate there, like so. Okay. Now we continue right now, then we look at more problems and more solutions. Right, I'm going to digress now from this notion of the exercises we're looking at, but to look at other problems that remain extremely important to us, that we must learn and take very, very seriously. And so, what are the methods that we need to learn here? Let's look at another question, another example. Okay, this one is an example that is from a past exam paper on the modified Euler. Just getting a bit more familiar with it, but it came in November. And here is the question. Use the modified Euler method with delta t equals 1 and with 2 corrections. Okay, the two corrections is always explained in this course. They always say 1 correction, one recorrection. Per step. Per step to find x1 and y1 for the initial value problem. T plus x plus y. Okay. Let me write like this. So that would be like dx dt is t plus x plus y. Initial value 1, dy dt is y minus x, y at 0 is 0. So we look at the solution to this. Okay. There are a couple of things we're going to write here because, okay, this is not exactly the one that came in the thing in November, but it's of this form. Okay, this one came in 2020, I think. The one I'm doing now, 2020 June. I was looking at the 2020 June paper. So the one that came in November, then I'm going to give it as a homework because I have access to it as well. So I'm just mentioning that. So in other words, by using now, the solution to this problem will be, because now there are two differential equations here. So, but how many variables are involved? There's an x at t and a y, x, t, and y, y, t, and x here. X, y, and t. So by using, so we're just discussing now, if there are two differential equations or there are three of them, what do we do? Or there are four differential equations, they bring a system of the differential equations by using the modified Euler method. We have the dx dt. According to this, dx dt is a function f of x, y, and t. But we have that x of x0, x of t0, x of t0 is x0. But we also have dy dt xyt, which is y0. Okay, so let's look at the predictor. What is the predictor? Okay, I'm going to look at a different version of the predictor this time around. So, well, it's the same thing, but the symbols. So if you can write the predictor like this, and it would be xt plus hf of xt, yt, and t. Okay, but also this has two differential equations. So there's x and y. So the yt plus 1 is yt plus hf of xt, yt, then t. Let's look at the corrector. which is t plus 1. Xt plus h over 2. Okay, so you have xt yt, t, plus f xt plus 1, p, y t plus 1, p, t plus 1. T plus 1, c, yt plus h over 2, which is g, xt yt t plus g of xt plus 1 p yt plus 1 p t plus 1 like this. Okay, so because there are two, this is the usual Euler, and this one is the corrector version of the modified Euler. There's pretty much nothing strange here, except that we have two differential equations. So we have a system of differential equations here. So let's just take a look. And so what do we do now? So in this problem, given the initial value problem, given that the initial value problem is dx dt t plus x plus y, and then this, okay, it's load shedding, load shedding, load shedding, load shedding, no power.